Bismillahirrahmanirrahim. Today we will cover the third part of our chapter 7, that is steering system, and today's topic we will cover three subtopics. First is the steering system analysis, then the wheel alignment principles and related alignment related problems, and then last is the alignment angles. So first 3 or 4 slides are from your book Fundamental of Vehicle Dynamics by Thomas D. Gillespie. I will be covering from those. Now, steering system analysis. We have talked about the major parts of the steering system: the steering wheel, the steering column, then the steering gearbox, and linkages. Now, further developing on the same, we now analyze the steering system. We have a different kind of configuration here. We have a rack and pinion in which we have a steering wheel here, steering column, and it is coming to the rack and pinion. And this is your rack and pinion. And then from here, linkages, it goes to your wheel. In the second figure, we have a steering gearbox in which we have a steering wheel here, steering column, and that steering column is coming towards the steering gearbox in which we have a gear arrangement, and from that gearbox it is going to the linkages. And in third, we have a steering wheel, then we have a steering column, a long one in which we have a truck steering system or the bigger or heavier vehicle. We have this kind of arrangement. Then we have a steering gearbox and or a rack and pinion here, and then we have a linkages here. So steering system analysis. The design of a steering system has an influence on the directional response behavior of a motor vehicle that is often not fully appreciated. The design of a steering system has an influence on the directional response behavior of a motor vehicle that is often not fully appreciated. The function of the steering system is to steer the front wheels in response to driver commands input in order to provide overall directional control of the vehicle. So the function of the steering system is to steer the front wheels, if it is a front wheel driven vehicle, in response to the driver's command input, with the driver which giving the command input, in order to provide overall directional control of the vehicle. However, the actual steering angle achieved are modified by the geometry of the suspension. So these are the factors which affects on your actual steering angle which we achieved practically on the ground. It is modified by the geometry of the suspension system, the geometry and reaction within the steering system, and in case of front wheel driven vehicle, the geometry and reaction from the drivetrain. So the actual steer angle which we achieved on ground is dependent or modified by the factors. Those are the geometry of the suspension system, the geometry and reaction within the steering system, and in case of front wheel driven vehicle, the geometry and reaction from the drivetrain. The lateral translation produced by the gearbox is relayed through the linkages to steering arms on the left and right wheel. Now, further, the steering system analysis. The kinematic geometry of the relay linkages and steering arm is usually not a parallelogram. Previously, we have talked about the parallelogram, this thing, but it is not actually the parallelogram, which the kinematic geometry of the relay linkages and steering arm is usually not a parallelogram, which would produce equal left and right steer angle, but rather a trapezoid to more closely approximate Ackermann geometry, which steers the inside wheels to a greater angle than the inside wheel. So basically, it's not a parallelogram arrangement. Basically it is a trapezoid, and more closely we name as Ackermann geometry, which steers the inside wheels to a greater angle than the inside wheel. The Ackermann geometry is illustrated in the figure A2, which is on the next slide. From analysis of the triangles, it can be readily shown that correct Ackermann geometry requires that. We will see that. First, see this trapezoidal geometry. You have a front left and right wheel. You have this steering linkages, and it is in trapezoidal shape. So if you want to turn right, the trapezoidal linkages will be in this shape. If you want to turn the left, the trapezoidal linkages will form this shape. So differential steer from a trapezoidal tie rod arrangement. Now, talking about this Ackermann geometry with respect to the angles, triangles, let's see the equations which we got. Now, this is your front of the vehicle. You are moving right wheel, left wheel, or outer wheel or inner wheel, front wheels and rear wheel. The distance from the front center of the wheel to the rear center of the wheel is called wheelbase, and distance from the left wheel to the right wheel is known as track, wheel track or track width. Now, this point is the center of gravity of the vehicle, and this R is the radius of the turn. So turn radius R. So theta I, delta I or delta naught, or outer, delta inner or delta outer. So if we want to find out the outer angle, how much your wheel has turned, so delta outer is equal to tan inverse wheelbase divided by the turn radius plus track width divided by 2, which is approximately equal to the wheelbase divided by turn radius plus track width divided by 2. So this is how we get the outer angle of your wheel, which how much your outer wheel has turned. Now, inner wheel, if we are turning right, and this right wheel has to turn more to cover to have that turning radius. So the inner delta I is equal to tan inverse wheelbase divided by R. R is the turn radius minus track width divided by 2, which is approximately equal to track base, the wheelbase L divided by the turn radius minus the track width divided by 2. So in this formula, we can find out the inner radius of turning radius and the outer turning radius of a vehicle in this manner. Now, second subtopic of today's lecture is the wheel alignment principles. Wheel alignment principle. Wheel alignment is the adjustment of the suspension and steering component angles to ensure proper vehicle handling with minimum tire wear. So we have to cater for the suspension system and the steering system, and we have to achieve a best possible alignments by incorporating these two systems together. So a wheel alignment is the adjustment of the suspension and steering components angles to ensure proper vehicle handling with minimum tire wear. The change in alignment angles may result from one or more of the following condition. The change in alignment angle may result from one or more of the following conditions, and there are three following conditions. Wear of the steering and suspension component. So we require the alignment. Number one, when there is some wear in the steering components or the suspension components, we require a wheel alignment. When there is a bent or damaged steering and suspension parts, so we require wheel alignment. Sagging springs, which can change the ride height of the vehicle and therefore the alignment's angle. So if there is something wrong with your springs system, which we are using in the suspension system, or with related to the wheels, so there's sagging springs which can change the ride height of the vehicle and therefore the alignment angles. So these are the three basic conditions which affects your wheel alignment. So we have to do the wheel alignment in these cases. Now the alignment related problem, pull. The first problem is the pull. A pull is generally defined as a definite tug on the steering wheel towards the left or the right while driving straight on a level road. So you are driving a vehicle, but your vehicle is pulling on either left side or right side. That is known as a pull. Bent, damage, or worn suspension and or steering component can cause this problem as well as a tire problem. So a pull is generally defined as a definite tug on the steering wheel towards the left or the right while driving straight on a level road. Bent, damaged, or worn suspension and or steering components can cause this problem as well as tire problem. Here in this figure, a pull is usually defined as a tug on the steering wheel towards one side or other side. So alignment related problem, pull is the first one. Second is the lead or drift. A lead or drift is a mild pull that does not cause a force on the steering wheel that driver must counteract. A lead or drift is observed by momentarily removing your hands from the steering wheel while driving on a straight, level road. When the vehicle moves towards one side or the other, this is called lead or a drift. So basically, a lead or drift is a mild pull. Its intensity is little bit less than the actual pull. So when it is intensity less, we call it as mild pull, and that mild pull is known as lead or drift that does not cause a force on the steering wheel that the driver must counteract. A lead or drift is observed by momentarily removing your hands from the steering wheel while driving on a straight level road. When the vehicle moves towards one side or the other side, this is called lead or drift. Third problem is the road crown effect. Most roads are constructed with a slight angle to permit water to drain from the road surface. Generally, it's the construction of the road is such like that we give an angle to the surface so that the water should drain out. Water should not stay on that surface. So the most roads are constructed with a slight angle to permit water to drain from the road surface. On a two-lane road, the center of the road is often higher than the berms, resulting in a road crown. Like in this figure, if we have a road like this, center is of the road is always on the higher path so that water should drain out on the sides. This is the crown of the road. The crown of the road refers to the angle or slope of the roadway needed to drain water off the pavement. So most roads are constructed with the slight angles to permit water to drain from the road surface. On a two-lane road, the center of the road like this is often higher than the berms. These are the berms, resulting in a road crown. So steering alignment has to be done in cater for this also. Next one is the vendor. A vendor is a condition where constant steering wheel correction are necessary to maintain a straight ahead direction on a straight level road. So in this wheel alignment related problem, a vendor is a condition where constant steering wheel corrections are necessary to maintain a straight ahead direction on a straight level road. So vendor is an unstable condition requiring constant driver correction. So this is another problem. Now the last two alignment related problems are stiff steering or slow return to center. If we have this type of alignment related problem, that is stiff steering or slow return to the center, hard to steer problems are commonly caused by leaks. Hard to steer problems are commonly caused by leaks, either low tire pressure due to the leak of air and or low lack of proper power steering due to the leak of power steering fluid. Other causes include excessive positive caster on the front wheels or binding steering linkages. So this is due to stiff steering or slow return to the center. Either there is a problem in your tire that your tire pressure is low, or there is a proper steering, lack of proper steering, power steering. The fluid in the power steering is low as from the required level, or there is an other causes include excessive positive caster on the front wheels of the binding steering linkage. We will study these angles later on. Last one is tramp or shimmy vibration. Tramp is a vertical type up and down vibration usually caused by out of balance or defective tires or wheels. So vertical motion up and down is known as the out of balance or defective tires or wheels, that is tramp or shimmy. Tramp and shimmy is the back and forth vibration. This was in vertical plane and this is in your horizontal plane. Shimmy is back and forth vibration that can be caused by an out of balance tire or defective wheel or by an alignment problem. So in vertical axis we have a tramp, in horizontal axis we have a shimmy vibration. So these are the alignment related problems. Now, alignment angle. There are basically three alignment angle: the camber, caster, and toe in or toe out. Now, first is your camber. Camber is the inward or outward tilt of the wheels from true vertical axis as viewed from the front or rear of the vehicle. Now, you are standing in the front or the rear of the vehicle and you see that your vehicle is tilt outward or tilt inward. So that is your camber angle. We will see what is positive angle and what is negative camber angle and what is zero camber angle. So let's see the right figure here. If you are viewing from the front and this your wheel is straight vertically aligned with your vertical axis, then we will have this zero camber. Now, in this figure, if you are viewing from your front and this is your vertical axis and but the vehicle center axis angle of the tire is like this. So this angle from the vertical reference and the angle of the tire is which the means the vehicle is tilt inward viewing from the front. So that is known as negative camber. When we have negative camber, we have the inner shoulder wear in this portion and scuffing in this inner portion. Now, if you are viewing from the front, this is your vertical reference axis or vertical straight line, and the vehicle or the wheel angle of tire is on the inclined towards the outside, and then this angle is known as, which is making from the vertical reference axis, vertical reference line, that is known as positive camber. So if we have a excessive positive camber, then the outer shoulder will wear this and scuffing will happen in this angle. And so these are the three sub angles: zero camber, in which the vehicle vertical reference axis and the angle of the tire is aligned, both axes are aligned and there is no difference between them, then it is a zero camber. When your wheel is inclined or tilt inward from the vertical reference line or axis, then we call it is negative camber. If the wheel is tilted towards outside or on the extreme side, then the angle from the vertical reference is known as the positive camber angle if you are viewing from the front or the rear. So camber is the inward or outward tilt of the wheels from true vertical axis as viewed from the front or rear of the vehicle. So this is your camber. Now, we let's see this positive. This is the vehicle weight of the vehicle or the vertical axis, reference axis, and this is your positive camber angle. The positive camber applies the vehicle weights towards the larger inner wheel bearing. Larger wheel inner bearing. This is desirable because the larger inner bearing is designed to carry more vehicle weight than the smaller outer bearing. So basically the larger bearing has to bear the more weight of the vehicle and the tire. So this positive camber angle is desired like this. Now if we have a negative camber angle, the weight of the vehicle is like this, the vehicle inclination angle is like this. Then the negative camber applies the vehicle weight to the smaller outer wheel bearing. Excessive negative camber therefore may contribute to outer wheel bearing failure. So this will happen if you have a negative camber angle or positive camber angle. The weight is shifted to the inner and the outer bearings. Now in this figure, we have a positive camber angle. The positive camber tilts the tire and forms a cone shape that causes the wheel to roll away or pull outward towards the point of the cone. But if we have a negative camber angle, it creates a pulling force towards the center of the vehicle that is not desirable. Here in this figure, if camber angles are different from one side to the other, the vehicle will pull towards the side with most camber angle. Let's suppose we have a vehicle in which your front wheel is we are having a 0 camber angle, and here we have a plus 1.5 degree camber angle. So vehicle will pull in this direction. So it has both tires should have the same camber angle. Now the second angle is the caster angle. Caster is the forward or rearward tilt of the steering axis in reference to a vertical line as viewed from the side of the vehicle. In camber, we are viewing from the front or rear of the vehicle. But in caster, we are viewing the steering axis and the tilt of the wheel from the side of the vehicle. So this is the difference in between camber and caster. So caster is the forward or rearward tilt of the steering axis in reference to a vertical line as viewed from the side of the vehicle. The steering axis is defined as the line drawn through upper and lower steering pivot points. So the steering axis is defined as the line drawn through the upper and lower steering pivot points. On an SLA, short long arm suspension system, the upper pivot is the upper ball joint and the lower pivot is the lower ball joint. From your suspension chapter, the line coming from the upper ball joint and cutting the lower ball joint, that is your steering pivot points. On an SLA suspension system, the upper pivot is the upper ball joint and the lower pivot is the lower ball joint. On a McPherson stirred system, the upper pivot is the center of the upper bearing mounted Mount and the lower pivot is the lower ball joint, because McPherson is different than the small SLA suspension system. So in McPherson's stirred system, the upper pivot is the center of the upper bearing mount and the lower pivot point is the lower ball joint. Zero caster means that the steering axis is straight up and down, also called 0 degree or perfectly vertical as shown in figures. Let's see, 14. So this both axes are aligned. Steering axis and the wheel axis are aligned. So this is we have a zero caster. In this, we have this vertical axis and the steering axis is like this. It is tilting rearward. If this is the front of the vehicle, then we call it as positive caster. If the steering vehicle axis is like this and your steering axis is tilting forward in this front direction, then we have this negative caster is seldom specified on today's vehicle because it tends to make the vehicle unstable at highway speed. The most common example we take for the caster is your bicycle front wheel. If you see the bicycle front wheel, your steering is handle is like this. So we have a positive caster angle. But this negative caster angle is seldom used because of unstable at highway speed. Now in this figure, as the spindle rotates, it lifts the weight of the vehicle due to the angle of the steering axis. We are turning in this direction, so it will forces are acting in downward direction here and the forces will act in upward direction angle due to this caster angle. So as the spindle rotates, this spindle rotates, it lifts the weight of the vehicle due to the angle of the steering axis. Now, if we have this figure, the vehicle weight tends to lower the spindle, which returns the steering to the straight ahead position, which turns the steering to the straight ahead position in this case. Now, if the caster is positive, like here we have the vertical axis or reference axis, and this is the steering axis, upper pivot and the ball joint. If the caster is positive, steering efforts will increase with increasing positive caster. Greater road shocks will be felt by the driver when driving over rough surface. So in this figure, vehicle with as many as 11-degree positive caster, such as many Mercedes vehicle usually use a steering dampener to control possible shimmy at high speed and to dampen the snapback of a spindle after a turn. High positive caster provides a road shock path to the vehicle. So it has to be within the limits. We cannot have so much positive caster angle. So vehicles with as many as 11-degree positive caster, such as many Mercedes vehicles, usually use a steering dampener to control possible shimmy. Shimmy is the alignment problem in the horizontal direction at a high speed and to dampen the snapback of the spindle after turns. So this is your steering dampener, which is used in the modern vehicles. Steering dampener is used on many pickups, trucks, sports utility vehicles, SUVs, and many luxury vehicles designs with a high positive caster setting. The dampeners helps prevent steering wheel kickbacks when the front tires hit a bump or hole in the road and also help reduce steering wheel shimmy that may result from a high caster setting. So we use this steering dampener. The third alignment angle is the toe angle. Toe is the difference between the front and the rear of the tires. Toe is the most important of the alignment angle. As viewed from the top of the vehicle, a bird eye views, zero toe means both wheels on the same axle are parallel as shown in this figure. Zero toe, note both tires are parallel to each other as viewed from the above. Now, first angle was the camber angle, which viewed from the front or the rear. Second angle was the caster angle, which is viewed from the side. Now the toe angle is viewed from the top. So this is your front wheels. The distance between the front right and front left and front rear, front right rear, left front rear. This distance, this distance and this distance is the same. So they are absolutely parallel to each other. So we have the zero toe angle here, but that is not desirable. So in this figure, the front distance from between the front tires is less as compared to the rear distance of the front tires is more. So in this direction, the both tires are not perfectly parallel. They will have this converging angles. So the toe in also called a positive toe angle. If we have this type of arrangement in which the front distance is less than the rear distance of the front wheels, we call it as a positive toe angle. If we have this type of arrangement in which the front distance is more between the wheel as compared to the front rear distance of the wheel, then we have this toe out, also called as negative toe. So upper case was toe in or positive toe. In lower case, when we have this front distance is more as compared to the rear distance of the front wheels, this is known as toe out or also called as negative toe. So these are the three alignment angles which we must cater for while doing the wheel alignment or steering alignment. Now, this tire is just 1 month old. It was new and installed on the front of the vehicle that had about 1 by 4 inches 6 mm of toe out, means negative toe. By the time the customer returned to the tire store for an alignment, the tire was completely bald on the inside. Note that the almost new threads on the outer side. So remember this thing. Whenever you change the tire, you change any suspension component, you change any steering components, first and most important thing after changing those components or changing tires, always do the wheel balancing and alignment and then drive the vehicle. It is very, very important for you, safety of the vehicle, safety of the passengers. So must do the wheel balancing and alignment. Now the total toe. The total toe is often expressed as an angle. If this is a positive toe angle, because both front wheels are tied together through the tie rods and the center links, the toe angle is always equally split between the two front wheels with the vehicles move forward. So the toe angle will always split between these two front wheels. So with this we comes the last slide of our this part 3. Now, first I will read this. While the feathers or the sawtooth tire tread wear pattern may not be noticeable to the eye, this wear can usually be felt by rubbing your hand across tread of the tire. So sharp edges points in the direction of the toe problem in toe in, out, toe out. So this is like feather or sawtooth tire wear pattern. So with this, we comes to the end of our part 3, the lecture of the 7th chapter, which we are studying.